Hello guys, my assigned topic is all about slope, different forms of equation of a line. So first, what is slope? Slope is a fundamental concept in analytic geometry that quantifies the inclination or steepness of a line. It is defined as the ratio of the vertical change, which is the rise, to the horizontal change, which is the run, between 2 points on the line. Slope is denoted by the letter M, and it has diverse applications in describing rates of change in various real-world scenarios. Slope formula refers to the formula used to calculate the steepness of a line, and it determines how much it's inclined. To calculate the slope of the line, the x and y coordinates of the points lying on the line can be used. In other words, it is the ratio of change in the y-axis to the change in the x-axis. Slope formula can be used to determine the slope of any line. The equation that can be used in finding this slope can therefore be written as m is equals to rise over run is equals to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, where m is the slope and x sub 1 and y sub 1 is the coordinates of the first point in the line, and x sub 2 and y sub 2 is the coordinates of second point in the line. So let us see the applications of the slope formula in the following examples. Example number 1 is find the slope of the line whose coordinates are 2 and 9 and 4 and 1. Slope of the line with coordinates 2 and 9 and 4 and 1, we have the solution is given x sub 1 and y sub 1 is equals to 2 and 9, then x sub 2 and y sub 2 is equals to 4 and 1. So to find the slope, we have the slope formula m is equals to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So to find the slope, we should substitute the value of the x and y coordinates. So the y sub 1 is 9 and the y sub 2 is 1. So y sub 2 is 1 and then y sub 1 is 9. So and then over our x sub 2 is 4 and then minus ang atong x sub 1 is 2. So simplify. So 1 minus 9 is equals to negative 8. Then 4 minus 2 is 2. So negative 8 over 2 is equals to negative 4. So our slope and the given coordinates is negative 4. So let's graph the coordinates 2 and 9, then 2 and 9, and then 4 and 1. And we have slope is negative 4. So to plot this, 2 and 9. So positive 2 are x and 9. 2 here. Then 2 and 9. Slope is negative 4, so slope is equals to rise over run. So our rise is negative 4, then our run is 1, positive 1. So to plot this, negative 4 is right, our right. So negative, so down tayo, down. So 1, 2, 3, 4. So down tayo. Then our run is to left. So run tayo ng 1. So here. So our next is here. Next point is here, then graph. So this would be our graph for the given x and y coordinates, and the slope is negative 4. So next is example number 2. Determine the value of b if the slope of the line passing through the points b and 7 and 8 and negative 5 is 6. So let's start. Slope m is given as 6 and we have 2 points on the point b and 7 and 8 and negative 5. Using the formula for slope, we have m is equals to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Substituting the values, we have 6 is equals to negative 5 minus 7 all over 8 minus b. So simplifying the equation, we have 6 is equals to negative 12 all over 8 minus b. To eliminate the fraction, we can cross multiply. 6 times 8 minus b is equals to negative 12. So 48 minus 6b is equals to negative 12. Moving the constant term to the other side, we have negative 6b is equals to negative 12 minus 48. So negative 6b is equals to negative 60. Solving for b by dividing both sides of the equation by negative 6, we have b is equals to negative 60 all over negative 6. So b is equals to 10. So therefore the value of b is positive 10. So next we will tackle about the different forms of equation of a line. First is slope-intercept form of a line. Second is point-slope form of a line. Third is standard form of a line. So first, let's discuss about the slope-intercept form of a line. Slope-intercept form of a line is a general formula for the equation of a line. Using the slope-intercept form of a line helps in finding the slope of a line from an equation and the intercept directly from the equation. The slope-intercept equation represents a line where y is the dependent variable usually representing the vertical axis, x is the independent variable usually representing the horizontal axis, m is the slope of the line, and b is the y-intercept, the point where the line intersects the y-axis. We have example number 1. Example number 1, find the slope of the line with the equation y is equals to 3x plus 2 and then graph the line. So the solution is in the slope-intercept form, the coefficient x represent the slope. So in this case, the slope is 3. So this will be our graph for our equation. Next is example number 2. Find the slope of the line with the equation y is equals to negative 2 over 5x plus 7 and then graph the line. So the solution in the slope-intercept form, and again the coefficient of x represent the slope. So in this case, the slope is negative 2 over 5. And then this will be our graph for the equation. So next is example number 3. Determine the equation of the line passing through point negative 2 and negative 3 with a slope equal to 1 and then graph the line. Our solution will be, since the slope is given as 1, we can substitute into the equation. Our equation is the slope intercept form of a line equation is y is equals to mx plus b. So if we substitute 1 to our slope, which is the m, so we will have y is equals to 1x plus b. Now we need to find the value of b, which represents the y-intercept. To do this, we can substitute the coordinates of the given point, negative 2 and negative 3, into the equation. So we will have negative 3 is equals to 1 times negative 2 plus b. So simplifying the equation, we will have negative 3 plus 2 is equals to b. So to isolate b, we can add 2 to the both sides of the equation. We will have negative 3 plus 2 is equals to b. So we will have negative 1 is equals to b. Now that we have the value of b, we can substitute it back into the equation. So we will have y is equals to x minus 1. So this will be our graph. Next form of a line is point-slope form of a line. Is one method to write the equation of line that starts with the slope equation, which is basically the difference between 2 points, and then rearrange the terms to obtain the point-slope form of a line. The point-slope form of a line provides a formula that is useful in finding slope of the line from an equation and a point the line passes through. The point-slope form of the equation of the line is given by y minus y sub 1 is equals to m times x minus x sub 1. So where m is the slope of the line and x sub 1 and y sub 1 is the point of the line. The following are the example of point-slope form of a line. First example is find the equation of the line passing through the point 4 and 5 with a slope of negative 1 and then graph the line. Solution will be given that the point x sub 1 and y sub 1 is 4 and 5, and then the slope m is negative 1, we can rewrite the equation as y minus 5 is equals to negative 1 times x minus 4. So simplifying these equations gives us y minus 5 is equals to negative x plus 4. Rearranging further, we get y is equals to negative x plus 9. And this will be our graph for the equation. So next example is example number 2. Find the equation of the line passing through the points 2 and 4 and 6 and 8. Then graph the line. So the solution will be given that the points x sub 1 and y sub 1 is equals to 2 and 4 and x sub 2 and y sub 2 is equals to 6 and 8. We can calculate the slope m using the formula m is equals to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. M is, we can substitute the value, so m is equals to 8 minus 4 all over 6 minus 2. M is equals to 4 over 4, and then 4 over 4 is equals to 1. Our slope is 1. So now using the point slope form, we have y minus 4 is equals to 1 times x minus 2. Simplifying this equation gives us y minus 4 is equals to x minus 2. Rearranging further, we get y is equals to x plus 2. And this will be our graph to our equation. Next is example number 3. Find the equation of the line containing the points negative 1 and 4 and 3 and 5. Our solution will be calculate the slope m using the given points. M is equals to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Substituting the coordinates point negative 1 and 4 and point 3 and 5 into the formula, we have m is equals to 5 minus 4 all over 3 minus negative 1. So simplify, we have m is equals to 1 over 4 or 1/4. Choose one of the given points. Let's say we have negative 1 and 4 and substitute into the point slope form. We have y minus y sub 1 equals m times x minus x sub 1. Substituting values, we have y minus 4 is equals to 1/4 times x minus negative 1. So simplify the equation, we have y minus negative 4 is equals to 1/4 times x plus 1. To convert this equation into slope-intercept form, we have y is equals to mx plus b. Distribute the 1/4 to the terms inside the parentheses. We have y minus 4 is equals to 1/4 times x plus 1/4. Isolate y by adding 4 to the both sides of the equation. We will have y is equals to 1/4 x plus 1/4 plus 4. Y is equals to 1/4 x plus 17 over 4. The next form of a line is a standard form of a line. This form is useful for certain mathematical operations such as finding the x and y intercept or when working system of linear equations. The standard form of a line puts the x and y terms on the left-hand side of the equation and makes the coefficient of the x term positive. The standard form of a linear equation is given by ax plus by is equals to c, where a, b, and c are constant, a and b are not both 0, a, b, c are usually integers. So we will have our example number 1. Write the equation of a line passing through the points negative 3 and 2 and point 1 and negative 4, and then graph the line. So the solution will be given the points x sub 1 and y sub 1 is equals to negative 3 and 2 and x sub 2 and y sub 2 is equals to 1 and negative 4. We can calculate the slope m using the formula m is equals to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Substitute the value, we have m is equals to negative 4 minus 2 all over 1 times negative 3. We have negative 6 over 4, and then simplify, we have negative 3 all over positive 2. Now using the point slope form and the point x sub 1 and y sub 1, we have y minus 2 is equals to negative 3 over 2 times x minus negative 3. Simplifying this equation gives us y minus 2 is equals to negative 3 over 2 times x. Rearranging further, we get 3 over 2 times x plus y is equals to 13 over 2. Multiply the equation by 2 to eliminate fractions. We have 3x plus 2y is equals to 13. So this will be our standard form of a line. And this will be the graph of the equation. So let's proceed to the example number 2. Write the equation of the line passing through the points 0 and negative 2 and 2 and 4. And then graph the line. Solution will be given the points x sub 1 and y sub 1 is equals to 0 and 2, and x sub 2 and y sub 2 is equals to 2 and 4. We can calculate the slope m using the formula m is equals to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. M is equals to 4 minus negative 2 all over 2 minus 0 is equals to 6 over 2. So simplify, we have our slope is 3. Now using the point slope form and the point x sub 1 and y sub 1, we have y minus negative 2 is equals to 3 times x minus 0. Simplifying the equation gives us y plus 2 is equals to 3x. So rearranging further, we get 3x minus y is equals to negative 2. This will be our standard form. And this will be our graph to our equation. So the next example is example number 3. Write the given linear equation in standard form. Y minus 5 is equals to negative 3 times x plus 4. The solution will be y minus 5 is equals to negative 3 times x plus 4. Then simplify, we will have y minus 5 is equals to negative 3x minus 12. So we will move the negative 3x to the other side. It will going to be positive 3x plus y minus 5 is equals to negative 12. So 3x plus y plus 7 is equals to 0. This will be the standard form of our equation. It will be the end of my discussion.